Welcome to Chandra's Edu. This is another video in the Artificial Intelligence playlist. In the last video of the Artificial Intelligence playlist, we discussed about the depth first search technique, which is an uninformed search strategy. So, in the uninformed search strategies, the first one is the depth first search, so which we covered in the last video. Now we'll be discussing about the breadth first search, and next video will be on the uniform cost search. So other than this uniform cost search, we have another three more uninformed search techniques which we'll be discussing along with this uniform cost search. But in this video, this breadth first search will be covered. So how the breadth first search works means it will just try to cover breadth wise the elements for finding the solution. It will explore all the elements in the breadth, or all the nodes in the breadth, that is at the level, to find the solution. If solution is there in that breadth level, it will try to cover that solution. If the solution is not present, it will go to the next level and search breadth wise to find the solution. So that's how the breadth first search works. So it will cover the breadth, and it will just, if the solution is not there, it will go to the next level and try to check all the breadth. And next, if the solution is not there, it will try to search the next level. And we will be taking here one example, that is about the binary tree example. The similar type of example we took for the depth first search also. In this binary tree, as we know, each node will be having two branches for a binary tree. So here we are taking the first node to be A. So whenever we are exploring A, it will try to expand the next nodes B and C. So after covering A in the level 1, in the level 2, the first element B will be covered, and whenever B is covered, it will try to expand the next levels of it, that is D and E. But they will not be explored, but only after covering the other element in that level C, the next next level elements will be covered. So after B, the next element explode will be B in that same level. So as the level 2 is also completed, it will try to explore the next level elements. So that is for the B, D and E will be explored, and after that C next element, that is F and G, will be explored. Next, this strategy is a simple strategy. As we discussed, it will try to expand root node first, then its successors, and then it will continue go on expanding the successors of the each level. And all the nodes are expanded at a given depth in the search tree before any nodes at the next level are expanded. So as we discussed in the binary tree example, we have two elements, that is B and C in the level 2. So whenever B is explored, D and E are expanded, but they will not be explored. Why? Because there is another element C in that level. So only after covering that shallowest node, shallowest is nothing but the next depth. So next depth is nothing but for A, the next depth is nothing but the B and C elements. When you take B, the next depth element are D and D, and for C also, at the same depth we have F and G. Next, we have it is an instance of general graph search algorithm, in which shallowest unexpanded node. So shallowest unexpanded node means, as we have seen in the last example. So first level 1 A is covered. The shallowest element is nothing but the next level, that which is nothing but B will be covered. So as B is covered, it will just check the in the same level uh, any other node is present. So we have C in that level itself, in that shallowest depth itself. So C will be covered next. Whatever unexpanded levels in the shallow are not covered, that will be expanded first, and after covering all that elements in that level, it will try to explore the next level elements. And this can be achieved by using the FIFO for the frontier. Frontier means, as we discussed in the last video also, if A is an element, the the nodes which are pointed from the A, that is, let us think B and C. So whatever this pointing from A to B or A to C, those are nothing but the arrows which are coming from that. We can call it as the frontier. So it will follow the FIFO queue to do this breadth first search. And the time complexity, as we have seen, there can be different branches, and even the so when you are taking an element A, it can have B, C, D. So that means three branches are there. So when you go to the next level of B may have E, F, and C may have G. So like that, the branches will be growing as we go down the graph or tree. So that you can find here, so the branch element may be a single B itself, it may be B square, B cube, so on. It will be increasing based on the depth. So if we consider D to be the depth, then the time complexity it will take is nothing but whatever all sum of these things, and that can be exponentially expressed as O of B power D. So, and one more thing is that every node that is generated must remain in the memory, as it uses FIFO, but every node need to be stored in the memory for knowing the next level elements of that of the level previous level. So memory is the main requirement, and even it is also having same space complexity as the time complexity. And advantage is that it will guarantee the solution uh, at the shallowest depth level. Why? Because we are trying to explore level wise. So level 1, so level 2 all elements are covered. So level 3, if the suppose that G is the goal, or we can say final state, then whenever it is exploring this level 3, we will just reach to the solution, even though there are other branches, further branches also. But in level 3, goal state is there or final state is there, then we'll get the solution, and the solution is guaranteed. So that is the advantage. Coming to the disadvantage, as I told, the memory requirement is more, and it's a bigger problem in the breadth first search than the time of exploring the elements. Why? Because just see here, in this example, first A will be stored, and the A will be expanded, that is B, C, D will be stored. So after storing A, it will be storing B, C, D. So A, and after that B, C, D will be stored. So it will just try to send out first in, as it is the first element which is in, it will be first out. Next, what it will do, it will try to explore the next elements of B. That is nothing but in this case it is E and F. So after exploring this, B will be sent out first in, as it the after A, B has come in, so B will be sent out. Next, after that, C, whatever the next element is there, that will be considered, and C will be sent out. So like that, each element need to be stored, and whenever it need to expand the next level, it need to know the previous element, so that need to be stored in the memory. So exponential complexity search problems cannot be solved by uninformed search methods. So exponential complexity means whenever we have more levels to be explored, so in that whatever the complexity is there, that will be exponentially high. And in the, if the number of levels are very much limited, and if the branches are limited, then the breadth first search can give the solution in a lesser time. So here is one more example which we discussed in the depth first search also. Here we will be using breadth first search to find the solution. S is nothing but the initial state, and G is nothing but the final state. And as the breadth first search, we will try to explore the shallowest node first, and the implementation as we discussed, FIFO queue need to be followed. So S initial state, so the next levels expanded are nothing but D, E and P. You can see each level is represented with a different color. You can find a different color for each level. So after exploring S, the next level expanded is D, E, F, D, E, P in the level 2. Let us take it as level 1, level 2, level 3, level 4 and level 5. So after exploring these elements, the next level after covering S, D, E, F, D, E, P are covered, and the D will be expanded next. So whenever we are going for D, it will be pointing to B as well as C as well as E. You can see the same thing over here, B, C and E. And next when we take in the same level E, it need to explore, it will try to expand to H and R, H and R elements. And in the same level we have P, so P is expanded to Q. You can find the Q here in the level 3. And then level 3 is expanded now. So in that the first element we have is B. So when we check B, the next level element can be A. Next when we check the C, that is for the D next level C, we have C. So when we expand this C, it will be pointing to the same A itself. And A does not have any further next element. Why? Because two arrows are pointed to A, but there is no arrow outward from A. So that here whatever this will be stopping here itself. But as we are exploring the level 3, we have in the level 3 E element. So E is pointing to R also. So you can find H and R. And even when we go to the E next element, there is level 3, another element we have is H. So when you see, we have an arrow from H to P as well as H to Q. You can see here H to P and H to Q. Next, the another element we have in that level 3 is R. We have path from R to F also. And even these two H and are also being covered. So when you go to Q, so Q there is no further path, so it will not be expanded. And next, after covering all these elements in the level 3, it will move to the level 4. So as we already discussed, from A there is no further expansion, so this will be stopping here, and even this also will be stopping here. Coming to H, so H we have arrows to P and Q. You can find the next level of this one as P and Q. And for R, the next level is nothing but F. And for P, the next level is nothing but Q. And for Q, there is no further expansion as we discussed. And next, coming to F, we have arrow to C as well as the G. You can find here C as well as G. Even this Q is also covered. So G is nothing but the goal state, our final state. So that means as we reach to the level 5, we got the solution. But even it may explode further also if we have multiple solutions. You can see for P, for this level 5 we have P, it can be expanded to Q. So you can see here P to Q, and from F there is a path from C, F to C, as well as F to G, F to C, F to G. So that means even in level 6 also we got the goal state. And then you see C, C also have an arrow to A, and after level 6 there is one more element. This Q no have no further element, and goal is nothing but solution, and here A is also having no further element. So after level 6 we can go for even level 7. Why? Because C has one more element, that is A, and no further levels are possible after A. Okay, so we can stop at level 5 itself, but even further can be explored if we want to find multiple solutions. So this is one more problem which we discussed in depth first search also. So the initial state is nothing but A, and the final or goal state is nothing but O. So we need to use the breadth first search technique for reaching from A to O. So first level 1, that is A, will be explored. You can find A will be explored. So from A it is expanded, that is B, C, D and E. You can find here B, C, D, and this is expanded. And in the next step, so B will be explored, and it is also expanded to F and G. And next you can see here when you are going for the next step, so it will be going to the same level of the B, that is C will be covered, and when we are writing also we'll be writing level wise. But in depth first search we have written the shallowest path first, that is a deepest path first, then we have gone to the another path. If the solution is not there, we'll once again track back and write separate path for the next path. Here it is not the same. Here we will be writing level wise. So as level 1 is covered, so we have written first element in the level 1, and next in the second level we have explored B. So B is the first one in that level, and C is the next element, and whatever the subsequent elements we can see the D, and the next element is nothing but E in the same level, that is level 2, is level 1. So you can find here level 1 and level 2. So whenever we are exploring any level elements, the next level elements will be expanded, but they are not explored. Okay, next when you go to the next level, the first element is F, then G, then we can find the next element in the level 3 as H, and next I is the next element. Next even J is also the next element in the level 3. This is level 3 solution. As all the nodes in the level 3 are covered, it will go for the level 4, where we have the first element as K. So F, no further element is there, so it will check G. So G next element is nothing but K, that is in the level 4. So level 4. Next we have element element L. Next there is no further expansion of H, but there is an expansion of I, which is M, and next expansion will be of J, the next element, that is N. So this is nothing but covering the level 4. All elements has been covered, and so it will go for the next level. So K, no further element is there. L, the next state is nothing but O, which is nothing but the goal state. So we have reached to the solution. And even further expansion may be possible if multiple solutions we want to explore. So H, no further for M no further expansion is possible, and for N also no further expansion is possible. And coming to the properties of the breadth first search, So we have the time complexity as we discussed earlier, depending upon the number of levels or tiers and the number of branches, we can find the complexity to be O of B power S. And here it is found using the shallowest, that means exploring the shallowest solution, that is shallowest depth we are considering to be S and the branches are to be B, that is, then it is B power S. And even when we take the space complexity, that is memory, also it will be taking same as the time complexity, that is O of B power S. But whether the solution is complete means it can be complete whenever S is finite. S means the shallowest depth at which we can find the solution. If it is finite, then it will be complete. Whether it is an optimal, if the costs are uniform, or we can say if the costs are one itself, then we can say the solution is optimal. So next video will be discussing about the uniform cost search, as well as other three more uninformed search strategies are there. We'll try to explore that in the next video. So keep watching Chandra's Edu, as well like, share and comment on videos of Chandra's Edu. Thank you.